Oh, okay. Hi everyone, Kem. Welcome to another session of the weekly circuit with Ethereum Nigeria. And this is the third program, or should I say the last program, or the final program, and the real life events we're having with Kernel Lab. And we have Speed from Kernel. Hi Speed, it's good to have you here.
Hi everyone. Happy to be here again for the third time. I am also a little bit sad that it's our final session, but you know, good things doesn't last long, right?
Oh yeah, that's very very true. So it's an real life event, and then for those joining us virtually, thank you, and you are welcome to this session. And we also have some people in real life at the Ethereum Nigeria Aka House. So I think from time to time, a lot of them will be popping in and saying hi.
Yeah.
And just to go over the agenda, for today, the agenda will be working, we're building two kernels and we'll also be building a smart contract to interact with that kernel. So I think it's going to be very, very interesting and interactive. And if you have not been following the session, there's both session one and session two available on the Ethereum Nigeria page. And I think for now, we're just going to go over like should I say like a recap of what kernel is all about, and we'll take a little bit of I think we'll take a little break, then we'll not dive right into what we have for today. So I think Speedy can take over just like a recap.
Yeah, thank you for that. So for those who are attending the event right now, I made a new page on our documentation. It's docs.kernel.xyz/workshop. I mean, it's funny that I found this a classic paint style. I mean, if you guys have used Windows XP before, it used to look like this on the MS Paint. So I just put it up. So yeah, we're gonna head to that page first before I give a little bit of recap, because we might need some time to get some tokens. So I'm gonna go to docs.kernel.xyz/workshop.
Okay. Okay.
So, okay, let me show this link again. So, in order to follow through this entire workshop, so I would recommend you guys to. Oh, that's my face right here. I would actually recommend you guys to prepare your wallet, either cold wallet, hot wallet. I don't know, medium cold, medium hot wallet, or whatever. Make sure you prepared like few things. The first thing is the Sepolia network, which is if you guys use MetaMask like me, I already enabled the Sepolia network here. So you can click on the top left of MetaMask and then scroll down. You can see we have the show test network here, and then you can see that we have a Sepolia here. Obviously, I already have some Sepolia token. Um, we also need to prepare the Oasis Sapphire testnet. I already put the chain list URL right here. So you can just come in here, click here, add to MetaMask. I also have that already as well. Let me show you. Oh, wrong tab. Right here. I already have some test token from Oasis Faucet. And also another network is we're going to use Arbitrum Sepolia. So important note here is that if you want to follow through, but you don't want to use Arbitrum Sepolia, that's fine. You can use just Sepolia. You can use Base Sepolia. You can use Optimism Sepolia. It's totally fine. Just pick one network that you like. But in my case, I just picked Arbitrum because I don't know. I haven't worked with it so much, so I chose them. So Arbitrum Sepolia, right here, same as Oasis Sapphire Testnet. Just click Add to MetaMask, and that should be on your wallet application, just like that, right? Um, and then what you need to prepare next is token on each network. If you have absolutely zero token on your wallet, we do provide the links to the most of the popular faucet. We do have a proof of work faucet, which that could take like 10 minutes to get like zero point 0.1 Sepolia token. That's why I want to jump straight into. Oh, okay. Thank you for that. um, we do have the easiest option, which is the proof of work faucet right here. It's free to use, and it takes a little while to actually just get like zero point 0.1 or even 0.01 token. So that's why I want to bring this up first, so that you guys can actually prepare while I'm giving you guys like some recap on the previous stations. You can also use Google Faucet. You can also use Infura Faucet as well. And for Oasis Sapphire Testnet, you have to use this link here, which they don't ask much. Just your wallet address. Oh, there's a captcha here. So you just put your wallet address here, click Sapphire, and then you can request for some token. The recommended amount is probably 0.1 Simply ETH. Obviously, you're not going to use 0.1. We're going to need only like 0.005 or something. But, just for the redundancy, for safety factor, for buffer, I just rounded up to 0.1. And also, same thing for Oasis Sapphire Tested as well. I believe if you click one request, you probably get like 10 test token or something, but I just put it as a guidance. Same thing with Arbitrum. You can use the bridge here from Sepolia to Arbitrum Sepolia. If you're planning to use other networks such as Base Sepolia or Optimism Sepolia, you might have to use another bridge. But there are a lot of bridge out there. You can use any. And while you guys are trying to prepare for the wallet network and also the token in each of the network. Oh wait, sorry, one more thing. Actually, while you guys are getting the token and preparing everything, it is nice to get the Etherscan API key as well. So in here, I have a link to how to get Etherscan API key, and if you come right here, you can actually follow the step. It's pretty straightforward. Just make an account on the top right. I already have an account, and then click API dashboard. I'm not gonna click it here because my API would actually leak my API key. But you can follow through and get the API key and save it for now. We will use them later. Also, same as Arbitrum. If you guys don't know, Arbitrum has their own blocks explorer, which honestly, they look the same. Like Etherscan and Arbitrum Blocks Explorer, they look the same. It's called Scan, and you would need to create another account. I mean, you can use the same email, same password, same username. Honestly, the same UI as well, as we can see. But we need to create the API key for Arbitrum as well, and we will be using these for the verification later. Um, so yeah, let me close this down. So make sure you have those. Make sure you have the tokens, and make sure you have the API key. If you're planning to, if you're not planning to use Arbitrum, make sure you have the API key from Optimism Scan. I don't even know what the name is. or the base scan. Technically, they all look the same. I believe they forked it from Etherscan as well. So, it's gonna be pretty straightforward. And while you guys are trying to prepare for the test token and Sepolia token, I'm gonna give you guys some recap of the of kernel labs, what we do, how our product works. So I'm gonna go to this
Okay,
page.
sorry,
Yeah.
speak sorry. So basically, the API key they're getting, it has to be from the particular testnet they're working with. So if they're working with base Sepolia, they have to get the API key from base scan. Yeah.
Yes. Yes. Correct.
Okay, so I think I have to clarify that part. So if you're working with Arbitrum, you have to get your API key from Arbiscan, or if you're working with just a Polia, you have to get your API key from Etherscan.
From Etherscan.
So
Yes. Correct.
yeah, I think it's a Polia.etherscan because if you go to Etherscan, you're working with the mainnet.
Um, Actually, they use the same API key for mainnet and testnet, so you can
Oh,
just get one, and then you can use across like all of the Etherscan ecosystem.
okay. No
Yeah.
problem. Thank you for clarifying.
Okay. Thank you for stopping me as well. I don't even know how fast I was going. Sorry for that. Um, so yeah, so while you guys are preparing that, I'm gonna give you some recap of what we do, how our product works. So Kernel Labs, we modified the Geth client, and what is Geth client, right? So in Ethereum, you have a lot of nodes. You have the execution layer, you have the consensus layer, and you have so many things going on right now because a lot of people built on top of Ethereum. Some companies, they even built on top of the top of the top of of Ethereum. I don't even know how that call anymore. Maybe like layer 10. That's actually a joke that we had in the company like few months ago. We were saying like, oh guys, look at that, we have layer 4 now, and oh wow, think about like 5 years from now we're gonna have layer 10. um so yeah, jokes aside, with in Ethereum, the majority of the execution the node in the execution layer, they are a Geth node, which stands for Golang, no, Go Ethereum. So you can guess, the entire node, the entire client is written in Golang as a language, as a coding language, and in the component of Geth node, there's a GraphQL inside of it. So Tahir, our CTO, he saw that this node has put a big potential, and he decided to study the node a few years ago. And time skip to like a couple years ago. He and Asim decided to make this company together. And what we do is we take the Geth client, the Geth source code, and we modify it in the GraphQL part so that the node is able to call the external function. And external function could mean um, web API, on any server out there, AWS, GCP, I don't know, Heroku or whatever, or it could call other blockchain network as well, because Geth is on Ethereum, right? But our Geth node, our kernel node, can actually call to other blockchain network, which currently we only have a few supported networks because we have been testing in only like few networks, but eventually it will open up, and technically um, we should be able to call any blockchain network out there. But for now, let's just focus to what we have now. So, for example, in this workshop, we're going to be calling a function on Arbitrum. So, what this means is that our final smart contract, our main logic code, is still on Ethereum, aka in this workshop, we're going to use Sepolia, right? Um, But before executing or making a call to this Sepolia smart contract, we can actually get some data or call function on other blockchain network, such as Arbitrum in our case. So that is what we do in a very, very simple term. And currently, we are about to get everything audited. I cannot actually disclose when will it be finished, and hopefully by the end of the year, we would get to mainnet, and hopefully we get to be the stage where our node is open source real soon, so that you know we could have technically anyone running our node. You don't have to trust us. You don't have to trust our company. You can just call any other kernel node out there from any of your trusted providers, and you can use our functions. And let's get back to the screen here. So this is the diagram that represents the steps and things that happen behind the scene when you're trying to call the main smart contract, right? Let's say your main smart contract is on Sepolia, but what's happening right before you call. So the first thing is that from a dApp or front end, a website, whatever you want to refer that to, like from a dApp would have to call the kernel node. Um, Kernel node would make a request to the list of predefined kernels, and kernels are, as I said, functions on other blockchain networks or web API, for example. And once all the kernels are executed in their own environment, the response will be sent back to the node, and then after that, the node will actually give the kernel responses. We're gonna call them kernel responses to token authority. What I here likes to see is that token authority is like a policeman. It's like a guy or a lady who takes care and oversees like the whole transaction flow, see if things go right, see if things goes wrong, and token authority can actually give the opinion on yeah, I agree, or no, this transaction should not be allowed. It's I mean, in simple term, it's just like that. But in a more deeper term, you feel free to actually read the code of our token authority. It's only like 300 lines long. Um, and once token authority give back the opinion, it will be sent back to the node. And then the node will send everything back to the dApp. And when I say everything, I mean the kernel responses and also the opinion from token authority as well. And then finally, we can actually make the transaction call to the smart contract by attaching like the token authority opinion and also the kernel responses. And later on in the session, I'll be showing you guys the I mean, I might be referring back to this diagram as well, but don't worry. I'll try to be, as precise as possible. Um, so I believe if you have been preparing the token and the API key, you might already be ready. So the next diagram that I would like to show is over here, which is the overview. I mean, previously it was named where to start, but now it's just the overview. And this diagram represents the steps and order or sequence of each of our targets. So we do have the kernel provider's path, which is the owner of the kernel. We do have the smart contract developer path, which is, you know, most of you guys, I believe. And we also have the depth path. And today we'll be, we are trying a different hat. We will be wearing three hats, even though I don't have any hat with me right now. I mean, I'm a hat guy, but my hat is like 2 meters away, or 6 feet. I'm not sure which unit are you guys using, but we're gonna try three different hats. So the first one, obviously on the diagram, we're gonna have to be a kernel provider first, and then we're gonna change our hat, and then try to be the smart contract developer, and then we're gonna change our hat again, and then we're gonna wear a dApp developer hat, and finally we can take off our hat and we can try our own dApp, which means that we even be like the fourth person as well, which is the end user. Um, of the entire protocol, right? So feel free to actually get back to this diagram anytime. I believe it's honestly, I made this one. It doesn't look good. I'm gonna be honest, but it does the job, and I just keep it there. So if you guys think you can make some improvement, I'm pretty open about it. Feel free to send it to my Twitter or anything. um, I'm happy to change it. So but for now, let's just keep using this one, right? So I'm gonna close this one. So the goal for the day, right? I think we mentioned it already, but I'm gonna walk you guys through the step by step of how to register, how to do stuff, how to set up everything, and also we're gonna focus on how to actually secure the bounty reward. Wink, wink. So for today, we're gonna build two kernels. The first one would be the exchange rate, or Oracle source. You can think of it as how do I say it? Actually, you can I believe you can just Google right now, like Web3 Oracle, and you're probably gonna see like one or two big companies out there. Um, it's probably going to be like on the first list of Google search. We're going to try to mimic that. And also the second one, we're going to try to build the allow list, or, think of it as like in NFT collections. Um, before the NFT owners, before they release the actual collections, they would want people in their like allow list to be able to mint or to trade or to sell. But in our case, we're gonna try to use that metaphor into our main smart contract. And the main smart contract that we're gonna build is gonna be the converting the mock ETH into the mock USDC. So I think that makes sense because we're going to be fetching data from exchange rate, and for the allow list, it's actually one of the most important use case of our product, because um, for the users that use our protocol, it actually helps with security measure as well. So that is what we are going to do today. And I'll be getting back to this diagram later on as well, so don't worry. Let me zoom out. Why do I have problem with zooming in and zooming out all the time? Uh, so let's build the first kernel, right? So let's wear the first hat. I'm gonna be the kernel provider now. So just to keep things like so separated, for the kernel part, I'm just gonna use Remix. I like Remix. It's free. So I'm gonna head to the Remix IDE here. Actually, you guys can also search it as well. Remix IDE. It's on the first link. Let's just open a new one. And then I'm gonna just create a new. Can you guys see that? Okay, I'm gonna just create a new empty one. So if Nigeria. Oop. Okay, and we have absolutely nothing on here. Oh, sorry. We have absolutely nothing on here except the prettier .json, which is just for prettiness.
Okay.
So
I see.
yeah,
Okay. Sorry to interrupt. No,
huh?
just sorry to interrupt. It's more like so. It's like a should I say like a 1 minute break, and welcome again to another session of the Ethereum Nigeria. And I don't know if you are watching this live, just give your reaction. And one thing to notice that you can also watch live on YouTube and also drop your questions there. So it's more like speed. Thank you for everything. Just like to slow down a bit so that
Yeah.
everybody else
Okay.
can catch up.
Okay. That's cool. That's cool. So should I continue?
Oh yeah, sure.
Okay. So if you guys just joined the workshop, make sure you go to this link, docs.kernel.xyz/workshop. You will see my face, and then just click there, and then what you have to prepare is some of these network on your wallet, just Sepolia testnet, Oasis Sapphire testnet, and also the Arbitrum Sepolia testnet as well. And make sure you have enough funds for all three testnets. I mean, you can use the faucet right here. You can bridge your Sepolia right here as well. And also, it's good to have the Etherscan API key just for the verification later on. Also, the Arbitrum scan, no, what's the name? RB scan API key. We do have the steps on how to get those in here. If you click this, just go to the link, click top right, register your account if you don't have them already, and just getting the API key and save those. We'll be using them later for the contract verification. So we were at the stage of we're gonna wear the kernel provider hat and we're gonna have our own kernels, right? So I just created a empty blank remix project here. So I'm gonna create a file which is named exchange.sol. I mean, feel free to name it however you want, like oracle.so, exchange.so, conversion rate.so, anything. It's totally up to you. And then I'm just going to copy this code here. I mean, keep in mind that this is just a mimic of oh, let me zoom in. That's actually super small. I can see that on the screen. Okay. Okay. So you can see that this contract, it's super like flat, right? It's super basic because what I would like to show is that um, at the end of the code, I mean, I was about to say at the end of the day, but at the end of the code, when you're trying to fetch the Oracle data, what you need is just a simple value, right? What is the conversion rate right now? What is the temperature out there right now? What is the day of the week right now? The answers to those are probably just, for the conversion rate, you probably just need like 2 to 1, 1 to 10, 20 to 5, something like that. It's just a value, right? It's just a data. What is the weather out there right now? 30 degrees Celsius, 60 degrees Fahrenheit, I don't know, 300 Kelvin. I mean, if people use Kelvin in their real life. Um, for day of the week, what is the day right now? Saturday, Sunday, Friday, right? And so on. At the end of the code, it's just a value that you're gonna need. So I'm trying to show that let's imagine that we have this value. We have the ETH to USDC conversion rate of 1834, which actually I get it from the April 1st, which is 18 days ago. Um, one ETH is equal to 1834 USDC. And let's be on the same assumption right now that for the whole of today, actually it's forever because it's on smart contract, right? But let's just assume that for the whole of this workshop, the rate of ETH to USDC is 1834. So we're gonna deploy this contract. Oh, I always have problem with zooming. I don't know why. Okay. Okay. Okay, that's fine. Okay. So in Remix, I can just go to the left here, Solidity compiler. For simplicity, I'll just use the same version which is 0.8.24. Let me zoom in. 0.8.24. I mean, in here, I put it as above 0.8.24, but I just use 0.24. I'll just click compile. And then, oh, that's done. I see the green tick. So next thing is I'm going to deploy. So I hit to deploy and run transaction here. I already prepare Arbitrum Sepolia network on my MetaMask, and also the Arbitrum Sepolia token as well, as you can see here. So I'm gonna click the environment here. If it's your first time using Remix, you might have to click customize this list, and you might have to enable injected provider here. So I already set that up. So let me close this down. Oh, okay. I already set it up. So it's there. Oh, okay. I'm gonna click injected provider, hyphen MetaMask, and we can see that the custom network here is you can see that, right? Oh yeah, you can see that. 421614, which is the chain ID of the Arbitrum Sepolia. So we're gonna hit down. How can I show it more better? Okay. We can hit down to contract. Just select exchange .sol here. I mean, if you use other name like oracle.sol, conversion rate.sol, or I don't know, abc.sol, just select the one that you have on your computer. And I'm gonna click deploy. Okay, my MetaMask pops up. I'm gonna click confirm here. Okay. Oh, that's actually pretty fast. We see the green tick here, and I have the contract address. So let's copy that. And we can actually go to Arbitrum scan, scan. Yeah, sorry. On the top right, I'm gonna click here and change to Sepolia testnet, Arbitrum Sepolia testnet. So I'm gonna click that, and I'm just gonna put the deployed contract address in. So let's just call this kernel A, right? Because in here, I put it as kernel A, which is the exchange rate. We obviously, we haven't verified it. We cannot technically read it. I mean, you could if you are a terminator, right? I mean, that's the that's the word that we called like within our company. But we are not terminators. We are not robots. Hopefully, anyone here a robot? So we're gonna verify them. So in Remix, you're gonna have to go to Plugin Manager at the bottom left, right here. Plugin Manager, click that, and then you're gonna have to search for verification. I already activated, but if it's your first time using Remix, make sure you activate this, and you can have this tab, Contract Verification, which in order to verify the contract on Arbitrum network or Arbitrum Sepolia, we would have to actually set up the API key that I mentioned earlier. Let me scroll up right here. Make sure you have the Arbitrum RBScan API key because we will use at this stage. But don't worry if you haven't had it. You can come back later. I mean, maybe almost at the end of every steps, and then you can verify. And then for here, I'll just use Arbitrum Sepolia. Okay, 421614. Let me pull it. Okay, and then I'm gonna paste the contract address in. Let me cross check if it's the same. Actually, I'll just copy it from RBScan as well. So let's remove this, paste it in, and make sure you choose the correct contract name here, because just in case you have a lot of contract on your environment. And if we scroll down a little bit, on your screen, I believe that the either scan tab here, let me highlight. On either scan tab here is probably not tick, right? What you have to do is you have to click enabled, just like this one actually, like Block Scout here. You have to enabled and then the question mark. Just click that, and then it would lead you to this settings tab, which it would say Arbitrum Sepolia rollup testnet 421614. Oh wow, that's longer than my grandmother's name. Um, so we can see that, and then if we scroll down a little bit on the Etherscan Arbitrum Sepolia here, you would have to edit this API key and then paste your API key down right here. And then for the API URL and Explorer URL, you can also take it from the workshop page as well at the top, at the above of the kernel A. You can just copy that as well and paste it on Remix IDE, and then click Save, and you should be able to verify on Arbitrum. Or, on another case, if you use just Sepolia, it would just be Etherscan API key. If you use Optimism Sepolia as a network that you deployed your exchange.sol onto it, just use that API key and their own network URL. No, not network URL. Blocks Explorer URL. But for our case, we are using Arbitrum. So let's click verify, yeah? And then that should take a little while. Okay, let me zoom out. Whoop. Wait until we have the green tick. Okay, and we have the green tick right here. So I'm going to head back to the RB scan, refresh one time, and we can see the code. We can see the code that we just deployed. That's pretty straightforward, right? So the next one, don't worry if you miss some part of it along the way, we'll do it one more time. So that is for the kernel A. So let's register them before we move to kernel B, right? Just to keep things separated. So just click this link below here, register, and then click that. It will lead you to our platform page. If it's your first time coming to our platform, just click connect wallet at the top right. But I already connected my wallet here. So I'm going to click register. And let me zoom in as well. Okay. And as we can see here, we have to choose either on-chain or off-chain. In our case, it's on-chain because it's on Arbitrum. So I'm going to change the network here. I'm going to scroll down a little bit. Okay. To see Arbitrum Sepolia. I'm going to click that. And then for address, this is the contract address of our exchange rate .sol, exchange.sol. I'm going to just copy address from here, paste it in here. For function signature, I mean, we have so many different names for just saying what is function name, right? We have function signature, we have function selector, we have function call, function name. I just call it function name. So we're just going to use it from here. This is function. So let me zoom in actually. Oops. Okay, so we have function. So I'm just going to copy this name here. Oop. And then paste it in here. Oop. Get exchange rate. And then for the function return type, in Solidity, it's quite straightforward because you can actually see it after the word returns here, right? I mean, you don't have to see what's going on behind the function. You can just take a look at here, returns with an S, and then you can even copy this. I'll just copy that and then paste it in here in the function return type. So other than that, we have the additional information like picture, upload cover image. That's totally up to you if you want to do that. But for me, I just want to keep it simple, so I'll just click activate. Let me zoom out. Okay. So on-chain, Abraham Sepolia, this is the address, 290, let's see, 290, function signature, I copied from that, return type, I copied from that as well, so I'm gonna click confirm. My MetaMask should pop up. Okay, I'm gonna click confirm. And while we are waiting for the registration of the first kernel A, I have a fun fact for you guys. Our our platform, the thing that you are seeing right here, we are trying to make a fully decentralized platform. We don't have any backend server. All the information that you just put here, it will be on our registry, which is, you know, a smart contract that you can register. We also have the detail here at the bottom left of the platform. We have the contract address. The part that we just register is the kernel registration, right? So you can see on kernel registry. And that's my, oh, that takes a while for indexing. Don't worry. But my kernel that I just registered like 2 seconds ago will be registered here. The goal is that imagine that tomorrow. I mean, I don't want to be too negative, but let's say tomorrow everybody at Kernel Labs we are leaving, right? Nobody actually working at Kernel Labs anymore, and we only have let's say we don't have anyone, even our co-founders, like they stop working at Kernel Labs. Our technology still exists. You can just spin up your own version of the platform. Just point to you know, to the registry, and the technology still exists and going without any problem. That is the goal. That is the one of the fun fact. So yeah, let's get back to the registration thing. So I saw one comment right here from Robert. Is it just Arbitrum network that kernel support? Good question. We also support, I think we support mainnet, Sepolia, base Sepolia, Optimism Sepolia, Arbitrum Sepolia as well. I mean, technically, we try to open up and, you know, support every blockchain network out there, but currently we have been testing in only like a few network. So it's just those for now, just for now. So
Okay.
let's get back.
So I wanted to like clarify to the audience. So at this point of the registry on the platform, when you are putting in, okay, can you go back to the page where you are registering? You have
Yeah,
to make sure the
this one,
network
yeah.
you're choosing is the network that you use to register. Like when you're doing the demo here, you choose Arbitrum because the smart contract you deployed was on Arbitrum,
Yes,
right?
yes,
Okay.
correct.
Also, one more thing. That means before you can come to the platform to register the smart contract, you have to make sure a smart contract has been verified on Arbiscan. Is that correct?
It doesn't have to be verified. It's just a lot easier when we can actually see the code, but it
Okay, so
doesn't have to be verified at all.
the verification kind of like builds trust so that anybody else can go on the scan and see the smart contract code.
Yes, correct.
Okay, very, very good. Sorry, I just wanted to clarify that. You can go ahead.
That's cool. That's cool. That's cool. Thank you for the question. So, yeah, let's get back. We have the what's next? Let's get back to this page. Kernel B, which is the allow list. Um, so, same thing. I'm gonna hit to remix. I'm just gonna create a new file and say allow list dot sol, and then getting back to the workshop page, copy the allow list file here, the piece of code here, And then I'm gonna paste it in. So what this does, it's pretty straightforward. We're just creating a hash map or key pair value or dict if you have a Python background. In Python, we call it dict, and or in Ruby we just call it hash. I don't know why all the programming language they just use like different keywords for this. They are technically the same thing. It's just key pair value, right? So the logic behind this allow list is that we are trying to create a mapping of your wallet address, which is 0x something something something, and then on the value we would have the true false. If you're on the list, it's a true. If you're not on the list, it's a false. It's as simple as that. And for this code, honestly, it's not actually like that secure because technically anyone can be on the list. We don't have any screening process. We don't have any how do you say, a guard to prevent this, allow this to be registered by everyone. But you know in a sense, I just want to show you that this is one of the good example of the use case, the application use case of using our whole protocol. So we're gonna have an allow list, which is same thing. We're gonna compile this allow list on the left sidebar. Click Solidity Compiler. Click Compile. I see the green tick here. So I'm going to hit to deploy and run transaction. And same thing, make sure you have the Arbitrum Sepolia on your wallet if you're not using MetaMask. I'm using MetaMask right here. And you're going to have to select the injected provider right here. If it's your first time using Remix, you might have to click customize this list and enable the injected provider hyphen MetaMask here. But I already enabled that, so I'm gonna click that. Make sure that the network here, let me zoom in. The network here is 421614, which is the chain ID of a Arbitrum Sepolia. And make sure you select the correct contract as well, which is the allow list. So I'm going to click that and then deploy. And then I'm going to click confirm. And oh, wow, that's fast. All these L2 are really fast. So we have the green tick here. So we have the contract address. Let me copy that. And I'm going to go to RB scan as well. I'm just going to open a new tab here. And then paste in the contract address. I mean, make sure you select the Sepolia testnet on the top right of RB scan. You can see we have the mainnet, and testnet. So make sure you select the testnet. Paste in the contract address, click search, and oh, this contract is already verified because I have deployed this contract before. It was actually like 2 days ago, and this is actually pretty cool from Blocks Explorer. Is that when you try to deploy the same contract as from the past, the new contract might be automatically verified because the Block Explorer will actually try to match the bytecode, and if it actually match, it would automatically like verified. That's pretty cool. But if it's your first time, I'm gonna show you again how to verify. So head back to Remix. Make sure you activate the contract verification under plugin manager here at the bottom left, and then search for verification, click activate, and then we're gonna have this new button here, contract verification, and then make sure you set up the Arbitrum Sepolia testnet. If you scroll down, on the Etherscan tick box, you might have enabled and then question mark. Just click that, and then you can actually provide the RB scan API key right here. And for the API URL and Explorer URL, you can take it from the code block above kernel A. Okay, so yeah, what you have to do is put contract address in, select the correct contract name, and then just click verify. So in our case, it's already automatically verified. That's a good thing. So I'm gonna hit back to the platform now. You can actually see it here as well. And I'm gonna hit back to the platform. It should look like this. I mean, for my wallet account, I already registered a lot of kernels for like testing. We use the shared account in the company, so that's actually a lot from everyone. So I'm gonna click register on the right, and let me zoom in. Okay, so the first one we can select on-chain because it's a smart contract function. And for the network, we're gonna scroll down here. Same thing, select Arbitrum Sepolia. And then we're gonna copy the address here. Let me zoom in. This is the allow list kernel, by the way. Allow list, you can see here. And then just put in the address. And then for function signature, it's just a function name. You can even scroll down here. And then I can, oops, sorry for that. Actually, let's use remix. I'm gonna copy this function name. Okay, check allow list. I'm gonna paste it in the kernel platform, but make sure that you remove the variable name wallet address input right here. So we should have something like this. Check allow list and then bracket address. All right. And then for the function return type, let's hit back to remix. We have the returns and then bool. So I'm just gonna copy that and then paste it here, bool, and which is boolean. So for the other information like pictures, it's totally up to you to upload or not. So I'm just gonna click activate here, and my MetaMask should pop up. Okay, that should take a few seconds. So what is the next thing? Oh, the next thing is you have to add yourself to the allow list as well, because well, what's the point of having the allow list if you're not on the allow list, right? So in order to do that, the easiest way that I think it should be is probably, I mean, since we are already on RB scan, and what is interesting about this block explorer is that you can also read or write contract here, which is, you know, in a more simple terms, you can actually call function, right? You can actually register yourself to be on the allow list in our case. So I'm just gonna go to contract here. You can see the code, and you can click the write contract and click connect to Web3. Okay, I'm gonna connect to Web3 here. And then I have the function of register allow list. And if I click write here, myself, I mean, my wallet address will be registered as the as it should be on this allow list. So click that. Click confirm from MetaMask. You should pay a tiny bit of gas fee on this case. So let's give it a couple seconds for the finality. Let's refresh one one time. Oh, okay, that's already done. So in order to check if you are already on the allow list or not, you can also come to the read contract tab here. Click connect to Web3. Okay, I have to connect again. And then we have the function of check allow list right here. And what you can do is just copy your wallet address, put in here, zoom in, and then click query. And we have a true, which means it's good, right? If you're on the list, it will return true. If you're not on the list, it would return false. So as straightforward as that. So that is how you check. It's fine if you couldn't actually register yourself to be on the list at this point, because I mean, in order to use our whole protocol, we have two major cases, right? We have the case where everything goes right, and you have a good transaction, um, or you can have a for example, in this case, you are not on the allow list and you should not be able to make the transaction, right? That's the idea. We have two major case, good case and not so good case. That's cool. But so yeah, don't worry if you cannot register yourself to be on the allow list at this point. That would mean that your transaction at the end of the session will not be 100% complete, but you can get back to here anytime, register yourself to be on allow list, and then you can make the good transaction this time. So that's done for the kernel provider path. So I'm going to take off my hat, and then I'm gonna wear a new hat now, and we're gonna be a smart contract owner, or smart contract developer, a developer who wants to use kernel protocol, KOS, kernel product. So currently we just launched our CLI. I mean, you can see it on the left here as well. We just launched a CLI, but I made this guide like a few days ago, so I'm still using the old method. Hopefully I'm not too old. I'm just using the old method, but it's fine, right? Because you can think of it this way, right? We kernel labs, we just provide the framework, right? We just give you the framework, the use case of it, or how you implement it. It's totally up to you guys, right? You want to use it in that way, it's totally up to you. You want to use it in that way, it's totally up to you. Also, same thing with setting up. We have so many methods of setting up um, the contracts and stuff. But in our case, we're just gonna use a simple git clone. So make sure you use this. I'm gonna copy this code. I'm gonna open my terminal here. Let's see if I have anything. Okay, I don't have anything. I'm just gonna paste it in. Git clone. I'm sorry, that's a little bit small. So I'm already done with that. So let's open it up. I'm using Cursor as the IDE, but if you guys are using VS Code, which is a really, really good IDE, that's fine. Technically, Cursor and VS Code is the same. We have the next thing is the fill the env file, or the environment file. So we try to keep things simple by all you need to adjust is technically in the environment file. So I'm gonna click the env example here. You guys are probably gonna have to fill in the private key and also the Etherscan API key. This is for the contract verification. I'm pretty sure that if you don't put the Etherscan API key here, the process of setting up the smart contract would probably fail at the smart contract verification. But that doesn't mean that your contract will not be deployed. the verification comes after the deployment. So it's fine if you don't have the key right now. But make sure you put the private key in here. It's not that you're gonna run the code and then I'm gonna collect your private key. No, no, no. It's it's just for the contract deployment. In order to deploy any contract, imagine that the whole network has to know who is the deployer, right? It's you. And how do you define yourself in Web3? You don't put email, right? You put private key. So make sure you put private key here. You can also use two separate key as well if you like it. You know, one for the token authority and one for the main smart contract. That's fine. Um, but while you are setting up, putting in the private key and stuff, make sure on line number 10 here. I'm not sure if that's too small. How do I zoom this? Oh, okay. Now I feel old. I, I don't know how to zoom on cursor. So on line number 10 here, make sure you change this to match with your um, kernel ID right here. For example, 1412 for me, and then another one. What is another one? 1413. 14, what was that? 1412 and then 1413. That is that is pretty crucial because what we are gonna do is we're gonna deploy our contract and we're gonna register through platform without using our hands at all. We're gonna just use one line and then we're just gonna chill for like 1 minute and then all the contract verification, contract registration will be done through the command line. So make sure you change that to the correct one. So for me, I already set up those in the another one. Let me pull up another of my IDE because I don't want to accidentally leak the private key. So I have set it up already in here. Um, um, Yeah. So in my case, I don't want to, as I said, I don't want to accidentally show you guys the private key. So I will probably use the old kernel from 2 days ago that I already deployed. But don't worry, it's the same. It's the exact same process. It's the same kernel, same everything, same network, same verification method. Um, I already registered myself to be on the allow list already as well. So I have the kernel ID of 1409 and 1410. 1409 is my exchange rate or Oracle, and 1410 is my check allow list. And what's next, right? Let's get back to the document. So I have filled the env file. I'm gonna just click the example here so that I don't accidentally show the private key. So I have the 1409, 1410. Okay, 1409, 1410. That's cool. So the next thing is we have to modify token authority because as I said earlier, token authority is like our policeman, right? But in this workshop specifically, I'm gonna try to be fancy a little bit by let me show you. I just paste the code here. Actually, can I make it full screen? Yep. Is that good enough? Okay, that's large enough. So I have the keyword here, which is here. So let's move down here. Typically right here, I mean, if you have read our documentation before, or if you have play around with our technology before, you would know that in order to set up token authority, you would have to do something like this: 1409 true, which is you would set the that specific kernel ID to be allowed, right? But in our case, in this case specifically, I will allow all of the kernel. Um, Let's see. We have a function named is kernel allowed, and I just remove whatever we have here. I don't even remember. You guys can do deep checker for me if you want. Um, but I just forced it to be true. So we are technically allowing all of the kernel ID because you know, I just want to show you guys that you don't always have to follow the code template that we have, like from the documentation or GitHub, or the CLI. Um, at the end of the code, I say that word again. It's like at the end of the day, we're just providing the framework. We're just providing example. It's totally up to you guys on how you implement it. Also, we have right here, which is on line number 92. Typically, right here is a part where we would compare the kernel response. Um, you know, Imagine we have a certain threshold on, let's say, if the score above like XYZ, we would allow the transaction, right? The token authority would give the thumbs up, and then the transaction should be allowed. Or, if it's less than the threshold, it should not be allowed. But in our case, we will allow all of the um, kernel responses. We don't care here. That is the idea of this token authority. So I'm gonna save the file and let's move on. So what's next? Pop this down. So the next thing is modify sample.sol. So this sample.sol is the main final smart contract, or I like to call it as the main contract, right? We do have the template, especially if you just freshly clone the repo, you would see the template. This is another template that I made it up, right? So what does this contract do? This contract is the main contract, as I said. And what's gonna happen is that it's gonna convert the mock ether into the mocking USDC. But why I say it's mock, because honestly, if you go through the code, um, you don't even lose any of the token. It's not even like ERC20. It's just a number. But if you think about it, right, in the world of Web3 and blockchain, um, every token out there, it's just a number, right? I mean, of course, yes, you have ERC20, you have standards, you have this, you have that, you have consensus, you have a lot of things to secure like each of the tokens. Some of the tokens might be um, referring to the real world value, such as like stablecoin, right? USDT, USDC, of course. But if you actually focus on it, it's just a number on the computer, right? It's just a number on the blockchain. So that's why I want to just show you guys the most simple way of of the tokens. We're just converting a number. So in here, what you have to modify is we have two paths here. We have the kernel ID of the exchange rate. So I'm gonna get back to the Google Chrome. Let's pop this off. Okay, my exchange rate is 1409. Okay, so I'm gonna change this to 1409, and then another one is the 1410, which is the allow list. So 1410. I'm gonna save, and that's pretty much it for the main final contract. I mean, um, I'm gonna give you guys some wink, wink here. Um, in order to secure our like bounty program, our bounty projects, you're gonna have to do more than what I'm showing you here, right? Because if you go through here, what I'm trying to show is just a converting number, right? And there's no like security on this. There's no like there's barely any checks on this one. We only have allow list kernel, which anyone can also register to be on that allow list. And also the Oracle source that we are using is just a static value, right? It doesn't actually refer to the um, actual current conversion rate at the moment. We're just using this static value. So um, I'm gonna give you guys more tips later on, but for now, let's deploy and verify and do everything, right? So what do we do? Let's get back here. I don't even remember the command line. Okay, we have to install the dependency first. So just gonna npm install. I believe that would take like few minutes. Let's see. Oh, that's actually faster than I thought. And we have the HDVR here, which is hard hat, deploy, verify, and register. So we're gonna do that. npm run dvr. You don't have to cd into any specific directory. You can just use the command like on the most outer directory of the project after you clone it, and also after you fill the env file, of course. So let's pull this up a little bit. Okay. So while we are waiting for that, I also want to show you the what I like to say the traditional method of registration as well. I believe some of you guys might have seen this already, but if you come to our platform, you can use the same link as you have it already before. If you go to Smart Contracts tab on the left, and then if you click Register, um, what you have to fill is the smart contract address, which is your main smart contract, right? In our case, it's the sample.sol. It's the address of deployed sample.sol. You may or may not verify. It's okay, you know. And the kernel ID, which is in my case, let me zoom in, sorry, 1409 and 1410. Like these two will be the kernels that I am running. And also the same for token authority, you would have to provide the address for token authority. And on our platform, we also have here, which is the hyperlink to, the documentation on how to build token authority. Also same here with the smart contract, how to, integrate your smart contract with our protocol. And after the registration from the contract, you would have the smart contract ID, right? And after you have the smart contract ID, you would have to also register DApp, which you have to come here, click register DApp, and put the ID in, let's say 123. Let's click this. This is the more traditional method, more old school method, which is just doing everything manually. And we understand. We understand that this is a lot of redundant process, right? You have to click here, come to smart contract, click register, put in the address. After registration, sorry, after like one registration, you also have to do another registration. We understand. We listen to you guys. So that's the main purpose of having our command line. I mean, if I haven't advertised it already, we do have the our command line, which would be on the left of the documentation. It would actually help you simplify the process of setting up everything, including importing the Solidity project into your machine as well. It's gonna be pretty fast. However, I'm still like old school guy. I said it already. I hope I'm not old, but I would prefer it that this way for now. So let's get back to our terminal. Oh, it's still verifying on the Etherscan, I believe. Oh, okay. We are registering. That should take only a few more seconds. Just ring smart contract. Okay. And we are done in like 1 second, I believe. Just ring DApp. Okay. Okay. So let's get back. Oh, where's my Google Chrome? So let's close this tab. So on our documentation here, you can see that the output from the running this command would give you something like this. You know, we have a long text and then summary, and then we have the contract ID, DAP ID, and stuff. And we have the link, something like this, right? Which is what we have. So I'm just going to click here, click copy, and then head back to Google Chrome. So right here, see, it's actually the same, right, as I showed you guys earlier with the random smart contract ID. What was the ID? Oh, 123 right here. We can do it like the manual method, which is using, click and type and copying and pasting, or you can use the preset command line, or you can use the CLI like from the left sidebar here as well on the documentation. But yeah, let's get back to here. So what's next? We have this page, we have the DAP ID, we have the entry ID, access token, and we have everything pretty much. So that's actually done for the smart contract path. So we're gonna take off our hat here, and then we're gonna wear another hat, which is a DApp developer. We're gonna pretend to be a DApp developer now. But I do understand that, realistically, in the world of programming, sometimes people just build their own backend and also front end as well. Sometimes people just, I mean, same thing with Web3, right? Maybe sometimes you build your own smart contract. You also build your own dApp. Or, you could be building smart contract, but not a dApp. Or you could be building a dApp, but not a smart contract, right? That's totally up to your goal and your career path. But, you know, let's try to be a full stack guy for a second, wear a dApp hat, and then we're gonna try to build a simple, very, very simple dApp here. So I'm gonna use a Next.js. So let's open this up here. Where am I? Okay. So let me clear this terminal. And this is just a typical command line for the Next.js, by the way. You can also search it on Google as well if you feel like you have seen it somewhere else. We also have another choice for simplicity. If you are someone who doesn't like to do front end work, like me, feel free to use Kernel Sandbox. One of our developers at Kernel, he built this, and then we install Kernel SDK within that dApp, and then you can technically call to kernel node using our Kernel Sandbox without any problem. But for our workshop, we're gonna try to be on our own. We're gonna walk on our own lakes, and we're gonna build our own stuff. So I'm gonna create the Next.js here. So I'm gonna just call it the Next JS, and we're gonna use a TypeScript. I'm pretty sure it's pretty straightforward for you guys if you have init the Next.js project before. It's not crazy. It only asks you for a few question, like, do you want TypeScript? You want a linting? You want Tailwind CSS? That's totally up to you. Oh, okay, that's done. So I'm gonna cd this in. Gonna open it on my IDE. Okay, let's close this down. Let's pop up the terminal here. Okay, and how do I zoom in again? Whoop, whoop, oh, okay. Oh, okay. I think that's better. So we have our Next.js. So what do we do? Let me get back here. We would have to install the kernel SDK. I mean, our kernel SDK is already on npm website. If you wanna see how it works, but um, technically we forked it from the ethers .js. We don't actually build it from zero. That would be like a hefty work, and that would take us probably like a few more years. Um, so we take the ethers.js and we fork it so that it can actually call um, our extra functions, right? So let's just copy this and get back to the Next.js here. Actually, let me move this away as well so that I don't open the wrong terminal. Okay, I'm gonna install kernel SDK. Okay, that's pretty fast, and I'm gonna just copy this code because that's the template that we are going to. Um, so we're gonna edit in source file, app, and then page, right? I'm gonna paste this in, and what we have to change are actually at the top here. So we have the entry ID, access token, deployed contract address, because in order to call the two smart contract, you need the address, right? And we also have the exchange kernel ID and allow list kernel ID right here, and the amount of conversion. So let's just go one by one, right? So the first one, which is what? Entry ID, sorry for that. So get back to the platform. I'm gonna click copy entry ID here. I'm gonna put this in, and then access token. I'm gonna copy that. Get back to cursor, paste in the access token. Also, this is probably not so good to put like all the entry ID and access token in this just one single file. I mean, in the production grade, you probably have to put it in the environment file. Keep it a secret. Keep it in um, GitHub credential or whatever. But for now, it's just for showing you guys. So the deploy contract address, thankfully we have it here as well. On the after the registration, we would have this smart contract address as well. So just gonna copy that. And exchange rate kernel ID, we have 1409. So 1409. And then the allow list kernel ID, we have 1410. And for the amount of ETH to convert to USDC, I'll just put 10 for now, because putting one might be too plain. So even though the whole script right here is already like super plain, um, we can also go through the code here. We have a lot of setups, hooks and like wallet components, and we have the RPC here, which is the 003. I said it at the beginning that we would be calling the node version 003, and the contract call method that we are going to use, we just use the interface from ethers. So technically, we don't need the ABI here on the dApp, and we can have few buttons to connect wallet. And what is also interesting is here. If you follow through on line 62 around no, actually 60 until like 70, we do have the kernel payload here. And what is kernel payload, right? Kernel payload is the parameter that will be sent to each of the kernel. So in our case, we have two kernels, right? We have the exchange rate kernel, and we also have the allow list kernel. The exchange rate, it doesn't take any input parameter, so that's fine, which is here. So that's fine, right? But the allow list, kernel, it needs the wallet address. So we have the encoded wallet address here, but I'm just gonna show you. Whoop, where is it? Okay, it's just the encoded parameter of EVM value. It's just padding, right? When you're trying to convert a wallet address, a dry wallet address. Is that a correct word? A dry wallet address, raw wallet address into the wallet address that would be the EVM compatible. You would just have to convert it, and it's all here. You can track back to see how it works. So this wallet address will be sent to the allow list kernel, and this will be sent to the exchange rate kernel, which is nothing. But what about the actual parameter, right? The actual value in our case is a mockup ETH that we will be converting to the mockup USDC. It's gonna be on the function params right here on the last bit of execute kernels function. This is a function that we actually made it ourselves actually. So we can actually trace it back as well. And you can see that right here, I have the U into 56 of amount of ETH to convert to USDC. And let's trace that back. So we just have, the first field line at the top, which in our case, I'll just use 10. So number 10 here would be sent to the main final smart contract. So if you're building this on your own, if it's a string, you would have to change this to string. If you're doing some other functions, you just change it accordingly. So, and then we have execute kernels, and then as I mentioned at the beginning, that this execute kernels function is the function that will be calling to the node, and then the node will call to the kernels, right? And then after getting the response, which is here, after getting the response, it will then finally be able to make the actual transaction to the smart contract, which we have it here as well. So just to show everything to you guys, so what is the command? Let's see. Okay, we have created the Next.js project. We have installed kernel SDK. We have pasted the code. We have filled everything. And let's go down here. Okay, just run def. Nothing more fancy. Okay, did I save this? Not yet. Okay, let me do it one more time. Okay. Okay, and for Next.js project, or most of the front end framework, you just use localhost 3000, right? And then, as you can see, I mentioned it in the beginning that this is a very very simple dApp, right? I mean, just to give you a little more of a hint, wink wink. In order to secure the bounty, you're gonna have to do more than just plain white background with like few buttons here. You might have to build an actual button called like connect wallet. You might have to actually make something more beautiful. So I'm just gonna connect my wallet here. Oh, let's see what's going on. Okay, I'm just gonna connect my wallet here and click make transaction. So that should be like few seconds. Okay, and my MetaMask pops up. So I'm gonna click confirm. And while we are waiting for the transaction, I saw a question from Robert. We need to write a smart contract for the token authority. Technically, you don't have to, because we already have the template for that. You don't have to write it yourself. You can just modify in just few lines. So we have the transaction hash here. So what's next, right? What do you have to do? What you have to do is you can go to Sepolia Etherscan, and this is the reason why earlier at the beginning I wanted you guys to actually prepare the Etherscan API key because after you deploy the contract, it's a lot easier to see things through using Etherscan. So I I just came to sepolia.etherscan.io. I'm gonna put the transaction hash in. Okay, let's give it like a few seconds. Okay, what's going on? Maybe it's not indexed. Am I on Sepolia? Okay. Okay, that's odd. So I'll just search it from using the um my wallet address instead. That's probably easier. Maybe I copied something wrong. Let's see. Okay. Du-du-du. Actually, yesterday Etherscan was on the maintenance as well. So I believe their server might not be 100% functional right now. So let's try to prove that by using another site. It's the Block Scout. Let's just use simply a Block Scout, right? We can come to here. It's the one with the nice cartoon logo here. Let's come here. It's the eth-sepolia.blockscout.com slash something. You don't have to use either scan API key here, by the way, if you use Blockscout. Let's see. Let's see which of my hypothesis is right. Let's see. Transaction. Okay. And I can see the contract here. Okay. So technically it was on Etherscan. Their server is probably super slow right now after the maintenance yesterday. So just to recap, what I just did is I tried to check my transaction hash. I tried to find a proof on Etherscan, and Etherscan website is super slow right now, but that's fine. This is Web3. This is blockchain. It's not like everything relies on them, right? When they are slow, we have to find the alternative, which I chose Block Scout. You can use eth dash sepolia.blockscout.com. And then I put my transaction hash here in this, and I could find that the transaction actually happened. It happened 4 minutes ago, right here. So, how can we check that we have all the success cases, like from everything we have been doing for the past few minutes, right? So, I can come to here on the contract tab, and I can go to read/write contract, which is pretty much the same as Etherscan, right? In Etherscan or oh, okay, yeah. In Etherscan, you have like the contract, the read contract, write contract. Same thing with other Blocks Explorer. You can also read, you can also write contract through the Explorer as well. And in our case, we have the read. Let me zoom in a little bit for you guys. We have the a function of CUSD balance here, which I would have to provide my own wallet address. So I'll just click here. And I'll just paste it here and click read. And there we go, guys. We have the 1830 no 8 what's how do you call this? No 18,340. Yeah. How did we get this number, right? This number is technically from our Oracle, our exchange rate. We have the fixed number of 1834 earlier. And we just converted a mock ETH which we put in 10, right? So at the end of the code, I think I said that 3 or 4 times already. So finally, ultimately, we have 18,340 because that's from 10 times 1834 from the conversion rate, and we are able to make this transaction without any problem because we are already on the allow list, which is the kernel B that we deployed earlier. Let's get back to here. I can actually show this one as well. So, so this is what I showed you guys like earlier at the beginning of the session, right? This is what we are gonna build, and we finally we built everything. Well, except the node, we didn't run the node like in this session, but we used the node 003. We deployed our own Oracle kernel. We deploy our own allow list kernel. We deploy our own token authority, and we also have our main final smart contract that would convert mock ETH into mock USDC, which I said mock like few times because it's just a number. It's not even ERC20 or anything. You can also refer back to the page of how does KOS work, and to see what's happening behind the scene when we try to click make transaction from this simple dApp as well, to see you know and I also have this tab, which is the bounty. I mean, if you guys don't have this already, we do have the form. It's a Google form to, if you guys um, built the bounty project already, just use this link. I'll just keep this link out, like always there. You can just come in anytime, submit the form will be there. I also have some other resources, such as our light paper. If you wanna be, if you wanna know, not wanna be, if you wanna know how we get to this point, our like co-founders' vision and stuff, you can read our light paper. And we also have other resources as well, such as in order to use off-chain kernel or web API into the blockchain transaction, you can follow this page. I have the list of supported network. I think Robert asked earlier. This is a list of our supported network right now to be a kernel, and we also have some simple guide for smart contract as well right here. I mean, the more detailed version, and also the dApp as well. But you can also just use my code example here earlier from the Next.js project to make a transaction call as well. I mean, we're just providing the framework. We are not actually trying to be the one and only answer to everything, right? And I also have this header here, which I think you guys might like it. Wink, wink. So this is the helper, right? The helper to actually help you guys secure like the bounty. I'm not sure if do we have 1 more minute, or do we have a few more minutes?
Okay, so we have like, okay, can you hear me properly?
Yeah, yeah, I can hear
So
you.
it's for 3 hours. We typically have like 1 hour.
I'm sorry, what was that?
I said we have like 1 hour. It's from
Oh, okay, that's cool. So yeah, I'll just be a little bit quick, so that you guys can actually try to get your heads down, and then building an awesome project. So this is the helper that I think it's pretty useful for you guys. We can take the example that I show you guys, like all the setup and everything, right? So what should be improved like for the whole of like 1 hour that we did. So the first thing is the exchange rate, the Oracle one, is not it's not dynamic, right? It's static. It's just giving out just one simple number. In reality, this kind of oracle, especially the conversion rate, they change by, I don't know, milliseconds. Um, in order to do that, I mean, that's a really big topic. Um, if you want to build your own oracle source, you might not have to be as precise as like milliseconds. You can just do like 10 seconds or even like a minute, right? But that's just a guidance. The allow list, or KYC type, it, as I said it earlier, it doesn't contain any like security check or proof or anything. I mean, you don't even have to make it like an on-chain one. You can make the off-chain um, allow list where you host your own database, and in order to be on your allow list, you have to follow your page on Twitter, for example, and you can be on the allow list. That's just one way of doing it, right? Um, Token authority, um, it allows all of the kernels, which is not recommended at all. Um, in the production grade, you should just fix the kernel ID on into the token authority. Um, it shouldn't allow like all kernels, because otherwise anyone could just trick your token authority by sending um, a fixed number from their own kernel and then give it to token authority, and token authority would just say, oh wow, that number is high, I like it, and then it goes on, right? So that's just one way of seeing it. um, the smart contract, the sample.sol, it's just converting the number, right? Not even ERC20, not even like any token. It's just a uint 256. So if you want to follow like this ideology of converting mock ETH into mock USDC, you're gonna have to deal with some standards, right? And so moving on to the DApp is pretty static, right? We hard coded the where is it? The amount to convert like at the top of the code. I don't think anyone do this. Typically, you should have like a text box, right, where you can put in the number of how much you want to convert, and then you click convert, and then boom, you switch from mock ETH into mocking USDC. Um, Also, the interface is nothing, right? We don't even have interface. We just have four sentences, not even a sentences. We have four phrases, and we have two buttons. That should definitely be improved. And also, I called it earlier already that there could be some vulnerabilities, especially on the allow list. Anyone can register themselves to be on allow list. We're gonna need more, more and more robust code base. So I guess that's pretty much it for this workshop. I'm not sure if some of you guys have any question right now so that I can answer right away, or if you have any question later, you can also ask on Discord and stuff as well.
I think there's a question. Okay, I think there's a question on the private chat.
Yeah.
Okay. Okay. Yeah. The question was like, do we need to write a smart contract for token authority? Like, is it something static, or we could rewrite the token authority to whatever we want?
Yeah, I think that's from Robert, right? So, um,
Yeah.
so token authority, you don't have to write it from scratch. We already have the template. What you have to do is just change. Oh, thank you for that. What you have to do is just changing like few lines of code. You have to match like your selected kernel IDs, and also just the data type from each kernel, and that's it. You don't have to deal with um, like 300 lines of code, because token authority is 300 lines of code. You don't have to write the whole 300 lines. You only need to change three lines.
Okay. So I think that's pretty standard. I think that's
Oh,
pretty standard. I think that's pretty
oh,
standard.
okay.
And okay, so one last time, can you go over like the flow? You know, we wrote four smart contracts. We wrote the allow list, we wrote the sample, and we wrote the exchange rate and the authority. So that's four smart contracts. So if we'll go through them again and explain what exactly is the kernel, or basically like the flow from the user perspective when they are using the DApp application that already built. So kind of like the user flow for that.
Yeah, sure. So for the let's start with the user's perspective, right? Imagine you go to like any website. Let's say we have this. Okay, I'm gonna refresh this. Let's say we have this as a dApp, right? How can I zoom in? Oh, there we go. Let's say we have this as a dApp. I know it looks pretty plain. It looks like a people who just use Google Drive to code. I don't know if that's possible or not. Sorry for that. So imagine you have a dApp like this, um, and then you want to swap from mock ETH into mock USDC, right? You would connect your wallet. Your wallet would be connected. I mean, that's my MetaMask, and that's my chain, which is Sepolia testnet. And let's assume that I'm gonna make a transaction. So I click this. Okay, that's gonna be okay. My MetaMask pops up. Um, and that's gonna be like a few seconds, right? Because you have to wait for, you know, the network. So technically, from the users, like end users perspective, you don't actually have to deal with all the setups, with like all the kernel payload, all the um, parameters and stuff. They only need to click, right? They click, which in our case is just two click, connect wallet and make transaction. Um, and that's done for the end users perspective, right? Um, but for the developers, I can actually get back to this page as well. Okay. For the developers, I mean, we have we do have three main audiences, targets, users. Whatever is the proper word for that. Um, so we do emphasize the kernel provider, or the owner of the kernel. We do emphasize the smart contract developer, and we also emphasize the dApp developer as well. So these three category, they are all considered as our main customers or targets or audiences, right? Whatever that is, whatever the proper word is. So imagine if you are the smart contract developer, which is pretty common in like Web3 community and blockchain space, right? You get into Web3, you want to be a smart contract developer. Um, so let's say you want to build your own smart contract of doing something, which in our case, we are swapping, right? We're swapping the ETH to USDC, but you want some layer of protection. You only want people from the allow list. Let's just say we have a really cool allow list here. It could be someone who follow ETH Nigeria. Otherwise, they cannot actually swap a token. Um, but you don't have to build that allow list, right? That allow list could just be, from a totally different person. That's why I was trying to wear a different hat earlier, because the first hat could represent, the first person, second hat like the second person, and then third hat like a third person, and vice versa. I don't know if that's a vice versa. So not only that, we can actually use the allow list, from someone else, but we can also use the exchange rate or oracle, from someone else as well, because building the entire oracle is not an easy task for sure. um, Otherwise, you know I'm pretty sure that everyone in the world can build an oracle source, right? In the current date, we don't have that much, reliable. I mean, let's just say we have some certain amount of the reliable Oracle sources, right? Where you can pay for them and then you can use their service. Um, and let's just say that they also register on kernel, and so now we have two kernels, right? We have the allow list of someone who follow if Nigeria on Twitter, they can be on the list. And also we have the Oracle source from a company, I don't know, ABC, for example. Um, and for us as a smart contract developer, we want to use those functions, right? So we just built everything through like KOS, through kernel protocol, register on platform, and then um, when we built our dApp, what we have to do is just install the SDK, the kernel hyphen SDK, and then we just set up the parameter to send to the Oracle source or to the allow list, which is the selected kernels that we showed earlier. And from the end user perspective, they don't have to know what's going on. They don't have to know what's happening. They only need to do 2 clicks, which is from this page. It's just 2 clicks. Um, does that make sense, or I have to actually show it on the platform again? Hello?
Yeah, I can hear you.
Yeah, I mean, does that make sense?
Yeah, it does. Sorry, it does make sense.
That's cool.
Okay. I think we have one question.
Yeah, sure.
I think we have one question. Yeah. Yeah. So we're going to bring him up. He's here in real life and he wants to ask a question. So we'll just give him a moment. And then I'm going to ask if anybody has any other questions. Okay. I think it can be this.
My name is Favor Joshua, and I have a question concerning technology that you are presenting today. You said in the token authority contract, we are supposed to like set um, the we are just to change the parameters because it's template already. We just change like the kernel we're using and down the token authority smart contract. What is going to be returned? We will just edit that part and just modify like a few bit of code. What if I working with two kernels? Are we supposed to have two separate token authority smart contracts, or we are just going to copy the code for what is supposed to return and duplicate it like in one token authority smart contract? I hope you understand what I'm trying to say.
Hello. Okay. Yeah, that's a good question. So so in do you guys see my screen? Oh yeah. Okay. So in our documentation here, if you go to the left sidebar on the smart contracts, token authority, how to build a token authority right here. Technically, you can copy this, and then you can even use the same. Oh, sorry, wrong one. Has to be this. Okay. Okay. Technically, you can even paste it here. Let me zoom out a little bit. Or should I zoom in? Let me see. Actually, zoom in looks better. And we are at tokenauthority.sol. And we can just paste everything in here. Whoop. Okay. I copied it from this. How to build a token authority under token authority under smart contract. I copy this. I paste it here. And we have just 3 steps. The first one is select the kernel ID, which is on line 57, 58, 59. I can just come down here. Let's say, oh, I can also use the existing one as well. So let's just use 57. I can just set it to, I don't know, 1, 2, 3. This one to 4, 5, 6. This one to, I don't know, 25, for example. And I don't want to run this one, so I remove this. I just save it. And now I'm allowing 3 kernels, right? If I have to get back to the top of the page, step 2, the decoding part from this TA contract is for comparing responses from kernel or, kernel responses. You would have to modify the data type to match with your selected kernels. So we have a line 106 and line 108. So let's find that. 106 we have here, and 108 we have here. So in this case, what do we have? Let me put a split screen here. Let me put this out. Oh, okay. I'm gonna scroll this up. Let's say we have kernel 1, 2, 3, kernel 4, 5, 6, and then kernel 25, which return int 6, right? So let's say we have 3 kernels here, right? This is the same file, by the way. It's just at the top of the page or at the middle. So the first one we have kernel 1, 2, 3. I can change this to 1, 2, 3, and then my kernel 1, 2, 3 is a Boolean type. I mean, this is hypothetical, by the way. So I just changed Boolean here, Boolean. Do I have to change something else? Okay. And for here, I would have to set it to true, for example. You can think of it this way, if it's true, good. I don't want to use the word bad, not good. And then if we have, in our case, we have 3 kernels, right? We have to deal with 2 more. So I'm just gonna copy this, for example, and then paste it here. And then change this to 456. And then it's a uint256. So, my AI just helps me. So I just changed this to uint256, uint256, results more than 0. Okay, that's fine. And then we have one more, which is kernel 25, which is int 256. And let's say this one we want it to be less than 5, for example. I mean, the rules, this is the rule part, right? The if result less than 5. Okay, I'll just change the number, result 25. So kernel 3, kernel 2, and then result kernel 1. I mean, just to show you that this is the rule that we can set. The criteria or the threshold of the rule, it's totally up to you. Because if you use, for example, the previous kernel that we deploy, we use the allow list kernel, right? That's a 0 and 1, right? You either in the allow list or you are not in the allow list. We only have 0 and 1 response, right? It's either yes or no. But if it's not a 0 and 1, let's say it's a gradient. Let's say it's a gradient, right? Let's say you have a reliable score. Everyone has 100 or 1,000. Let's say 1,000 score. And for malicious actors or malicious users, they might have 500 instead of 1,000. So you would have to set the threshold, right? On which level should be the certain amount that you want to allow the transaction to go through. For example, let's say kernel 2 here is the gradient that I'm talking about, and you want the result to be above 500 here because you want to protect your main smart contract from malicious actors. So that is the, this is the token authority. I believe we also have the step 3, which is the node whitelist and runtime digest. I mean, currently, if you're planning to use just 001 version of the node, it's fine. Everything works fine. You don't have to change anything. But if you want to use the 003, you would have to change the runtime digest here. I believe that the digest is not on the documentation yet. I might just put it up for everyone as well. So yeah, that's gonna be my on my side. But if you use 001 node, that should be fine on step 3. So is that more clear on your question earlier?
It's clear on my end, but do you mind just one more question? Because I didn't like start like this program early.
What was that again?
I said that I have one more question. And, I would like to know if like on your the platform, if you this goes to his dashboard or something on your platform, you can where they give you the option to deploy a kernel. I saw a list of different networks there. I want to ask whether like this technology we have addresses like network abstraction. Like if my smart contract is on another network and the kernel or my kernels are on different other networks that is supported on um, your technology, will my workflow yield results, or I have to have everything on a single network?
I'm sorry for that, but can you repeat that again? I mean, your mic is a little bit low on the volume.
Okay. I want to ask if okay. I want to ask about, because when you were going through like the process and everything, if user is registering a kernel, or let's say it's deploying a kernel, a smart contract, you can deploy it on the available networks that you, your technology currently supports, the Arbitrum, Sequoia, or Base, and the rest. I want to ask if this your technology addresses like network abstraction. If my main smart contract is on another network and your remaining like my other kernels said custom kernel and I use one of the kernels that's on the platform already, will they all have to be on the same network or can they be on different networks as far as those networks are supported by your technology? That's my question.
Yeah. Okay. That's another good question. For the account abstraction thing, that's gonna be the future version of the node. Currently, our team is working on that. I know the details, but I don't think I can explain to you right now. That would be the future update of the node. Eventually, um, we would have the node that could actually call the transaction on other blockchain network as well. Of course, using account abstraction, but how we do it in detail, I cannot actually show you right now. Or actually, I should say I shouldn't show it to you right now. That could be like a secret, but yeah, that's a very good question. Thank you.
Yeah, that's it.
All right, thank you. Okay, thank you, speakers. Okay, thank you for that speak. I'm going to keep go around and ask if we have any more questions, and I'll also check online if there are any more questions. High speed. So
Yeah,
we have the developers in real life, and then we have a bunch of them that want to say hi to you.
yeah.
Okay, and I'm going to pass the mic over to them.
Okay, let me go straight there.
Yeah, they want to say hi together, right? For the poll. Let's say hi together. Let's say hi together. Then do it.
No, it's not.
Okay,
Just tell,
So,
are you backstage?
tell Steve that your colleagues.
Okay, is he on the StreamYard link already?
yeah,
Yeah.
Okay, it's not. Where is it? Okay,
So, let me make the most like that.
okay, we have one more person joining.
Everyone is there.
Okay,
Your device is not connected. Why? Why?
one more person is joining in. We have like a full house, and is going to join in shortly. Mm,
Yeah, yeah.
to Robert. Robert, what happened?
Yes. Sunny, you want to fight? Okay, see, no noise.
Okay, Robert, I'm passing the mic to you.
Hello, sir. Hey,
Hello.
yeah, yeah. So, Robert by name, a blessing, Jennifer. So, looking at to my team actually building like a couple of projects. So, but then, looking at the kernel network, I mean protocol. So, I don't know how we can like integrate our projects into the KRNL network. So we are building two projects currently. One is a pivot, right? And the small project basically allowing professionals, career persons to like build their CVs, their resumes, and also their portfolio on chain. So I don't know how we can like integrate the kernel into our project. So I don't know if like there are like any requirements in our project in this particular network.
I'm sorry, but I think something is blocking your microphone. It's pretty low. Is it connected? I mean your microphone. Can you repeat that again?
Okay. So can you hear me clearly?
Yeah, it's pretty hard to catch the word. I'm not sure if your microphone is connected to the laptop or not.
Let me just
Yeah,
better.
yeah, yeah.
Can you hear me?
Oh, Oh, it's oop, I think that was the same microphone, right? It's a laptop microphone, yeah.
Let me just use your tablet.
Okay, I think it's just going to use mine. The echo
Oh,
is
yeah, yeah,
pretty much.
yeah. That works as well.
Okay. Yeah, I think that's okay. Somebody's blocking this stuff. Yeah, sorry. Okay.
Okay, hello.
Hello, can you hear me now, Space?
Yeah.
Can you hear
That's
me now?
pretty cool. Yeah.
Okay, so I said I'm Robert by name, and I'm a blockchain developer. So we're working on a couple of projects currently, like a few projects. So the first project is allowing professionals and careers to, upload their CV, their resume, and also their portfolios on chain. We're actually like building a decentralized storage that allows them to store this particular file. So I don't know how we can like integrate the KRNL protocol or the network like into this project that we are building. So if you like could share more insights on how we could like go about this. And I think you're talking about the token authority, how we need to like write smart contracts for the token authority to like verify our contract and all of that. Like if you could like share more insight on how we can like enhance our projects. Yeah.
Yeah. I'm sorry. What was the second one? Token authority. What again?
So
What you were saying about token authority again?
yeah, so I was saying that yes, I was saying that we are building a file vault like a decentralized storage that allows career person like professionals to like store their CV, their resume, and their portfolios on chain. So we also integrated like an AI feature that allows them to generate their CV on chain. So my question is, how can we integrate the KRNL protocol? Like, how can we integrate this protocol to our projects? Yeah, that's what I meant.
Oh yeah. Okay, that makes sense. I mean that is a really good project, I think. Because in order to upload like professional CV and PDF file on chain, that's not easy. Um, but I'm I'm not sure about how we can integrate with each other right now, because what I mean when you refer to like uploading. Oh, okay. Hello, hello, check. Okay. Oh, hello. Oh, okay. Thank you. I mean, when you refer to the uploading the like the CV and resume, that's actually pretty cool because I recently just read about a blockchain network called Arweave. Um, they are doing what you just actually mentioned. Technically, you can actually upload, right? I mean, we can just use that word. We can upload any text or a file like onto the blockchain network. That's what they are doing. I just recently read about it, and what is interesting is that I mean, for Aviv, it's gonna be quite tricky to be working with our protocol because the foundation of Arviv is it's not like any other blockchain network because for for Ethereum we have execution layer, we have consensus layer, we have proof of stake, and we have a bunch of more things, right? For Bitcoin you have proof of work, um, which in some sense Ethereum and Bitcoin can have some similarity, But from what I read from Arviv, it's so different on the foundation that they are trying to make, because they have the approach of, you know, they want to be the network that can store, pictures, videos, files like forever, right? um, Even the gas fee is so different, but that is a very interesting topic. So I would like to, take like probably like few hours to think about, how we can integrate with each other, if you don't mind. Um, can you maybe after this event, can you text me on either Twitter or anything? I believe you
Okay.
have my Twitter, right?
Okay.
Yeah, you can just like drop a link so I can like text you on X. That's fine.
Yeah, yeah, yeah. Oh yeah, X. Yeah, it's the new name. Yeah, yeah. That would be
So,
cool. That would be.
yeah. So one more question, like I want to ask, do you think that we can build a payment solution? Like we are looking at payment infrastructure. Like, do you think this can work on the kernel? That's all.
You mean for the
Like,
image?
no, no. Like I'm talking about something else entirely from the file listing. So I was asking that, do you think building a payment infrastructure on KRNL network like looks suitable? Like, is it okay? What do you think?
Um, I mean, we are not trying to build a network. We are just modifying the node. The network is still Ethereum, right? So eventually, imagine, 1 year from now, 2 years from now, 5 years from now, Ethereum, like the whole Ethereum ecosystem might have, Geth node, Reth node, um, and so on, right? You have like Prism, which is the consensus layer. We have, I don't know, Parity, we have Nethermind and stuff. And, kernel node should also be like on that part of the ecosystem as well. We are not trying to um, make a new network. And also, um, hopefully at the end of the year, um, we would hopefully we would finish like all the auditing stuff, with all the auditing companies, and we can give the code to the node runners, such as, you can think of the node runners, right? Like Alchemy, Infura, DRPC, I don't know what else, Quick Node and stuff. We have been talking to some of them, and hopefully, by the end of the year, we can give them the code, and then they can just run uh, a kernel node for us, or even like a cluster, of kernel node for us. Actually, not for us, for everyone, so that you don't have to call, 003 dot RPC something something anymore. You can just call kernel dot infura, for example, kernel.infura.com or something like that. That is the goal right now.
Okay. Thank you very much. I really appreciate it. It's nice chatting with you. Thank you.
Thank you. Don't forget to text me on Twitter. Yeah.
Yeah, sure. I will. Thank you.
Thank you.
Okay. Thank you, Speed. That was a very, very wonderful session. So currently we have like a full house of developers and they're really curious about kernel. So we really appreciate this session. And I don't think we have any more questions. I'm going to pass it to Mr. Enoch. Yes. To like, we still have like 16 minutes more. It's a 3 hour session, so we have like 60 minutes more. And Mr. Enoch maybe could give some like Mr. Enoch. Yes, who's my sister? Okay. Is the founder of Ethereum Nigeria and is basically the man in charge of everything. So all through the session it has just been me and you. So I mean, like this is like the should I say the last program or not the last collaboration between Ethereum Nigeria and Kernel Lab. So I just want to give him like the opportunity to say one or two things before we come to the end of the session. Okay. So for everyone joining us virtually, this is the third session with Kernel Lab and also the weekly circuit for Ethereum Nigeria. And Speed, I think you shared a web page that docs.kernel.xyz that also contained the workshop.
Yes.
Oh yeah. So for anyone joining the workshop or you want like a recap of the workshop, you can always go to this URL and get a full breakdown of the workshop and also deploy your own kernel. Okay. So just hold on a bit,
Okay.
Mr.
Can
Kiss.
can you hear me safe?
Yeah. But
Can you hear me safe? Yes, sir, can you hear me? Okay. Speed, we just want to appreciate you for uh, being very detailed. Kind of like take it from from the grass, and we're just growing up from each session. It has been quite educative, and it's something that our developers are quite excited to explore. And technically, we posted about the 100 plus active builders in Africa, and I'm working closely with ESE, so and we've seen interest from South Africa, we've seen interest from Morocco, and some of our network in Kenya and stuff like that. We have to see how we could, you know, get them more ship their products on the canal. Um, so I think we just have like a close chat group where we iterate on how to go about this. And as a matter of fact, I think we have like 4 projects right now. I think we'll be going with you after like on the back end to see how we could ship these products to Kernel, and then see necessary support that you could help. So we're working closely with SA on this, and I think the grant, the 8,000 grant is still on. So we'll pitch this to them yesterday, and we want to see how amazingly some of this, most of the solutions are like very simple, usable, right? It's not something that you ship and get abandoned. Example like the attendant, it's just a whole lot of them. Case studies on read. So many of the on fintech as differ as well. Yeah. So let's thank you once again. Want to appreciate Canal and the team at large for sponsoring this session, and we're happy to like get you guys down to the blockchain week in Africa. So we hope to spin it up across different locations. Um, so we're talking much more. So guys, uh, yeah, it's I just want to appreciate the team at Ethereum Nigeria, Ese, Tete, and many of our guys behind. I just want to appreciate your support, the creative teams. You guys are so much wonderful, and the guys in the kitchen, the chef. I can see the our lunch is quite ready. You guys virtually just want to give you guys really a big thumbs up. We're hitting like a landmark 141 viewing right now. Um, uh, we need to like post our telegram right now so that you guys can join the canal session. So there is this bounty um, promo right now, like kind of like encouraging builders to build whatever product you're building right now. It ranges between $50 to $1,000. Calm down. So you could just join our Telegram group, and tag Essay, tag myself or Etete, so that we will give you guys a proper directions. We're having 142, 141 right now. So we want you guys to just go. So follow us on Telegram. Esther, can we just hold the Telegram group on X so that you guys could join? I think from my end, um, yeah, just want to thanks the builders in Nigeria as well, across Africa. We can't wait to like spin up the next boot camp, strictly on building and canal. Um, yeah, that's over to you.
Thank you for the remark.
Hello. Oh, okay.
I think
I
that's
was on mute.
it.
So yeah, thank you everyone. I mean, thank you, if Nigeria, but also the most important part that I want to say is thank you all the attendees. Right? If you don't have the watcher, who are watching this live virtually, and if you don't have you guys who came to the event like in person, we wouldn't have this event at all. Um, you know, I just want to thank all the attendees. All the event joiners. Even though you can just little things, I don't know, because maybe I'm just mumbling, and maybe I'm just speaking too fast. Sorry for that. That's why we have the I'm not sure which way. Is it this way? docs.kernel.xyz/workshop. You can roll back
All right,
and follow the
Etete,
steps.
could you just let's see your handsome face? It's CTO.
Oh, hello. Is he gonna say something? Oh, I think you say is disconnected, right? For some reason. Okay. I guess while we are oh, yeah, there we go.
Okay, sorry for that. I'm back. And yeah, we've come to the end of this session. Thank you for watching, everyone. Thanks to the Kernel Lab team, to the Ethereum Nigeria community, and we hope to continue this conversation on the Ethereum Nigeria Telegram. And if you missed most of the part live, you can also go and rewatch on YouTube, and you can also watch on the X channel. So I think join the Telegram for the bounty. Oh yeah, there's a bounty to build with Kernel Lab. Create your own kernel, and you stand a chance to win $50 to $1,000. But I don't think that's the main focus. The main focus is coming in and making use of this amazing technology, because I feel like the Web3 space is all about the innovation you can bring. And I think we've come to the end with that. So thank you, Speed, and have a wonderful rest of the day. So if anybody else can unmute their mic or say their cameras, so that would be amazing. Oh yeah. Oh,
That's cool. That's cool. Thank you, guys. Thank you, everyone, for attending.
I'm here. Okay. We sign up.
You can do it.